So here's the process. We have, just to kind of draw the components, we have, and this is going to look silly, but it's super important. This is the image that you're supposed to have in your head. We've got paper. It's got stuff on it. It's got writing on it. And we've got a human who is looking at the paper. And they have a pencil. And so what they are doing is they're staring at the paper. So let's inspect this process, and let's think about how the process goes. Oh, and then there's one other thing. I have the person looking at the paper, which is kind of, but their brain is the main part. So let's put, in place of their brain, let's put a thought bubble. So now we have all three components. We have the paper, the pencil, and the mind. And so let's think about what's going on. And let's make a few observations. So the first observation is incredibly important. So at any moment, at any particular moment, we can only focus on a limited part of the paper, portion of the paper. And we're also in a particular state of mind. So let me kind of discuss those two things individually. So when you're drawing something, right? Let's think about just the act of drawing something. When you're drawing something, you are not looking at the whole thing. You're looking at a particular chunk of it, right? You're looking at like maybe this area of the paper. So, and you can only do that, right? We can't focus on the whole world at once. We can only focus on a little piece of it. So that we're focused on a particular part of the paper at any moment. We're also in a particular state of mind. And so what I mean by that is maybe I'm thinking along the lines of I am searching for a word. Maybe I'm looking through this paper looking for a specific word somewhere. Maybe that's my that's a state of mind, right? I'm in the act. I'm telling myself I am in the act of looking for a word. Maybe more generally I could say something like I am turning left. Maybe I'm driving. I am in the act of turning left. That's what I mean by state of mind. And another one maybe is like I am planning to say something. I'm listening to you talk, and I have my own thing prepared that I'm going to say in response to the thing you're saying. I am prepared to say something. These are all states of mind. That's what I mean by this. So that's what I mean by states of mind. And so I'm going to give this a definition. So the pair that is the small region of focus on the paper together with the state of mind, we will call the context. I'm going to call that context. Those two things together form the context of the computation as it's going on. So the context of a computation is going to be the region of the paper that I'm focused on, and then whatever state of mind I'm in. This and this together make the context. And so what's going to happen? Based on our current context, we perform an action. The action consists of three parts. So so we are reacting to our context. One step of computation, of human computation, is having context, and then reacting to that context with action. And so the action is going to consist of three parts. So in my mind, it consists of three parts. One, it consists of an alteration to the paper. I write something down. So for simplicity, that it's what's altered is the part of the paper being focused on. That what's altered is what's focused on. In other words, I'm not gonna alter some region that I'm not looking at. Of course, there are people that juggle, right? There are people that can do all sorts of weird stuff. But let's just assume that if I'm going to change anything on the paper, it's going to be this in the box right here. And again, that shouldn't make any computation impossible. You know, I mean, if there's obviously not going to be anything that is limited other than, like, you know, inconvenience, right? So there's an alteration to the paper. 2, a shift in focus. So I'm gonna move my focus somewhere else on the paper. So maybe, you know, I move over here. Maybe now this is my focus on the next step, right? So a shift in focus. And then 3, finally, a new state of mind. My state of mind might change, right? Maybe I found the word, and now I'm in a state. Now I'm doing something with the word, right? And I want to note that this guy here is internal. External. That of these 3 actions that are taken at once, this is an external action, and then these 2 are internal. So things are occurring in 2 different areas. Things are occurring in the environment, and things are occurring in my head. But the action involves both changing. The state of mind is changing, and so is the paper, and they're both changing in response to the context. So what we've just described here is a step of human computation. So we've just described a single step of human computation. We now have a new context. What we're left with is a new context, right? I've changed the paper. I'm looking somewhere different. I've got a new state of mind. It's this again, but it's different. It's the same picture, but it's a new version of the same picture. And now the process repeats. And the process repeats. Eventually, maybe, we may reach a particular state of mind which corresponds to being done. Right? The computation ends when I decide it's over. Right? I mean, eventually I'm going to do enough steps, and then I stare at this and I'm like, oh yeah, I'm done. Right? And that's a state of mind, and that concludes the computation. So eventually we enter a halting state, essentially. A state of mind that corresponds to the computation ending. And so that is the dynamic process. So there's a lot to unpack here. What we just described. So computation is a dynamic interaction. It's a dynamical process in which mind, pen, and paper all interact and influence one another in a sequence of repeated reaction. I'm not going to say that, but I am going to describe what I mean by that. So we should talk a little bit about dynamical systems here. What is a dynamical system? What do I mean by this? It's pretty simple. A dynamical system is a process that is continually reacting to its own output. So we can come up with all sorts of very simple examples of this in math. So for example, one very simple example would be um, uh, double it. That's a dynamical process. Start with 1, and then 1 becomes 2 if I double it. But now I have a new output, right? So then I'm reacting to this 2. Now I'm doubling the thing I just spat out. So you can kind of think of, if you think of the dynamical process and then you double that, you get 8. And then you double that, you get 16. This is a dynamical process. We've got this kind of machine, T. I'll call it T. We can kind of think of it as a box that's doing something. I'm feeding things into the box, right? So T is going to spit out a 2. So spits out 2. If T spits out a 2, then 2 goes back in the box. If 2 goes back in the machine. And now it spits out a 4. And now 4 goes back in the machine. This is a dynamical process. It's a dynamical process because it is continually, you're continually taking the output and feeding it back in as input, right? And that's exactly what's going on with computation. What's going on? How is this a dynamical system? Well, we're taking the context. The context is both the input and the output, right? We take in context, we do something in response to that context, and then we get a new context that feeds back in, and then we process that context. So that's kind of computation. And we can draw a nice picture. So the picture I just drew is kind of a generic dynamical system, which the cybernetics people would like to draw these boxes, and it's like this, right? It's outputting something, and then that output goes back in, and we can think of computation this way. I can think of a computation this way easily. I can say just this is the computation box. I guess I would really call this the control, or the control plus environment. Or the control plus the store, I guess. And I'm continually spitting out contexts. And then the contexts feed back in, and then I do something to the environment and change my state of mind based on the context, and then I get a new context, and I spit that context back in. So I'm repeatedly spitting out contexts and taking in new contexts until I have arrived at a conclusion and the process concludes. So it is a dynamical process. It's a dynamical system in which the mind and the pen and the paper all interact. And so I want to make this I want to kind of expand this out, because this right now is not useful. This is trash. Let's make it better. To make it better, we have to turn back to Turing. So let's think about really what's going on here. So we've got mind. Let's think about the mind and the paper specifically. So we've got mind and paper, and the mind is continually reacting to the paper. Right? I look at the paper. I obtain contexts. So what's going on here is looks at paper, gets contexts, and then it does something to the paper. And then I get a new context, and then I look at the paper again, and I get a new state of mind, and then I keep processing that. And so this is a feedback loop. This is a dynamical process, and it's also a feedback loop between the mind and the paper. And if you want, you could go ahead and replace the mind and the paper with the more general notions, right? What Turing would call the mind is instead, well, what Turing would generalize the mind to is he would call it the control. And what Turing would take the paper and generalize it to is the store. And so computation kind of more generally is anything like this. And I can go a little further. But I mean, because there's 3 things, right? Because and the thing that's missing from this diagram, I think this diagram is in many senses the best one to stare at. But there's a third one. There's a third step that I can add in a third box here, because the control can't just alter the store. There is a mediating force. There's a pencil in the middle that is the mediating factor that allows the control to influence the store. So we've got the mind again, and it's got the paper. we've got an interfacing factor, that is to say the pen. So the mind observes the paper, takes in a context, and then it changes the paper using the pen. So this is the mediating device. So this is the executive unit. So to kind of replace this with control, to replace this with executive unit, and to replace this with store, is to finally kind of get back to what Turing was originally talking about. And now we can see very clearly that Turing's three kind of essential components are his way of documenting a dynamical system like this, in which the control is continually influencing the store by means of the executive unit in this looping process. It's a dynamical process between those three things that he described. Okay, so that concludes the first chapter, I guess you could call it, of this series of talks. What we have arrived at is we have a pretty solid understanding now about what human computation is. And we also have started, following Turing's lead, to generalize that idea of human computation to a more general setting. And I'm sure a lot of you in your heads have already started to do that, especially those of you that are familiar with Marxism, because if you're familiar with Marxism, then you're familiar with a certain base superstructure diagram. And I'm sure you're looking at this right here and saying, hey, wait, this is just that. This looks identical to that diagram. And I kind of said earlier that any process like this can be seen as computation. And so there's an obvious thread to pull on there, but I'm going to show some restraint and not pull on that thread yet. There's some more things that I feel like I need to say before I can arrive at that. And I also want to back up and I want to approach that diagram from kind of the bottom. So we're going to hold off on that obvious comparison to make, and we're also going to hold off on doing more examples besides human computation. But we will get to more examples of computation. We will think about computation a lot more generally than just human computation. But for now, let's stick to this. Let's pretend that we're only thinking still about human computation, just for a little while.